Hi, once again. Hope you are doing well. So today I'll be doing Newton's laws. Please do not forget to hit on the notification bell so that you can be notified when you upload new lessons, and please like, comment and share the video. A 4 kg block is pulled up along a frictionless incline by a constant force F acting parallel to the incline as shown in the diagram or is shown below. The incline makes an angle of 30 degrees to the horizontal. Then it says constant velocity. The block moves at constant velocity. It means that F net equals 0. Why? Because acceleration is 0 whenever they say constant velocity, not constant acceleration. I hope that makes sense, guys. So when you see constant velocity, they want us or they are actually telling us that F net must be 0. Why? Because acceleration is 0. I hope that makes sense. Sometimes they can say constant speed, so on the same thing, F net equals 0. But if they say constant acceleration, F net cannot be 0. I hope you understand that. So our block is on an incline surface. So they want us to state Newton's first law of motion in words. 3.1, let's state it. When you state it, you say a body will remain in its state of rest or motion at constant velocity unless a non-zero resultant, or you can say net force, acts on it. This is how we're defining it. Now they want us to draw a labeled free body diagram showing all the forces acting on the block. 3.1. So a free body diagram is indicated by a dot, but now since it's 3 marks, you must know that we're having 3 arrows pointing away from the dot. Therefore, you must actually draw the incline, then you put the dot in the middle of the inclined plane. Therefore, you can draw the normal force. It is not vertically upward, but it is perpendicular to the surface. This is Fn or N. And what else? Fg. We have Fg or W, the weight, gravitational force. Then we are given F there, or you can say Fa, up an incline. This is Fa. So this is 3 marks. This is how they mark the free body diagram. Since it's 3 marks, they're going to mark Fn, Fa, and Fg. So all the time, make sure that you show the incline. It will make things to be easy. So they want us to calculate the magnitude of the perpendicular component of the weight of the block. So these are the components of Fg. Fg equals mg sine theta. That's Fg parallel. All the time you use these ones. Therefore, Fg perpendicular, because they say perpendicular, mg cos of theta. Therefore, you're going to substitute the values here. We do have the value of m, which is positive 4 into 9.8 cos of 30. You just punch this in your calculator. You're going to have we just use my calculator over here. It's 33.95 Newton. Remember, this is a force. I hope you understand that weight is a force. This is how you're solving it. Then 3.32, they want us to calculate force F. But now let's actually erase this one here and continue. No, actually, maybe we'll need this 3.31 somehow. Let me try to restore what I actually erased. Let's see. Oh, we have 3.95. Okay, but it's fine. Now they want us to calculate force F, or we will need the free body diagram. Let me just restore. Okay. I can just write 3.95 Newton and remove or erase 3.31. Okay, just try to calculate this one. 3.32. Therefore F net equals MA, and we are told that the block moves at a constant velocity. That makes F net to be 0. Why does MA substitute 0? Why? Because M times 0, it will be 0. There's a mark for that. Then the forces that we must substitute right here on the F net part are forces that are parallel to the direction of motion. Those forces, before you can do that, you must actually show us the components of FG perpendicular and of FG parallel. So this is where it's showing us FG parallel. This is our FG parallel, and you can see that FA and FG parallel are parallel to the direction of motion, these two. So FG is down and incline, it will be negative. It will be negative FG parallel plus FA equals 0. Therefore, let's make FA the subject of the formula, since we are to calculate it. FG parallel, we transpose it to the right, it will be positive. Therefore, MG sine theta, then what is the value of M? It's 4. G is 9.8. Then what about C? It's not C. Sine 30. You punch this in your calculator, you're going to have let me try to use my calculator. Is 19.6 Newton. So this is the value of FA or F. I hope it makes sense, guys. So I think we can actually continue answering the questions, okay? Let's try to continue. Now, the same block is now pulled up along a rough incline by a constant force of 25, and they said rough tells us that frictional force by a constant force of 25 Newton acting parallel to the incline as shown below. The incline makes an angle of 30. Then the acceleration of the block is now 0.2, meaning it is now moving, it is no longer stationary along the incline or upwards. Calculates the magnitude of the kinetic frictional force acting on the block. 4 marks. They want what? The value of Fk. We can use what? F net equals ma. It's no longer 0. Why? Because it is now moving. They gave us acceleration, right? Minus Fk plus minus Fg parallel plus Fa equals ma. It is the same object, it's just that there's what it is moving now. Minus Fk, what is the value of Fg parallel? It's mg sine theta plus Fa equals ma. Therefore, let us substitute everything that we're having. Minus Fk minus, what is the value of m? It is 4 kg into 9.8 sine of 30 plus Fa, which is 25 that we are given. 4 times 0.2. Therefore, when you punch everything in your calculator, negative Fk, let me just use my calculator right here. Okay, let's use the calculator. Please bear with me, I'm just punching this in my calculator. It's going to give us negative Fk Therefore, the answer of this is going to be 5.4 equal to 4 times 0.2 is 0.8. Therefore, transpose the 5.8 to the left, to the right. Therefore, 0.8 minus 5.4. It's going to be negative. All right. It's going to be negative 4.6. Therefore, you divide both sides by negative 1, then it's going to be 4.6 Newton. So this is the value of the magnitude of the kinetic frictional force acting on the block. I hope it makes sense. Okay, 3.42. I hope you understood 3.41. They want us to calculate what the coefficient of kinetic friction, and this is the formula that we use, mu k n. Then they want us to find what mu k. We do have the value of fk. So for us to do so, we must actually have the value of normal force and fk. So if you watched the first part and the second part, we talked about the formulas of calculating Fn. If you are given this type of a scenario, this is the formula that you must use. But if you are given this type, you use this formula to calculate what Fn, which is Fn equals mg f minus fa sine theta. But now, since we are given that one, this is the formula that we're going to use right now. Meaning, if you are given an incline, Fn equals what? The perpendicular component, of which is what we were calculating in question 3.31. So that's value, it is equals what? The value of what? Of the normal force on an incline. I hope it makes sense. We'll actually have the same answer here, cos 30. It will be what? You punch this in your calculator, it will give you what? That 33.95 Newton. So the value of normal force in an incline plane in this question equals what? The perpendicular component of the weight or of the gravitational force. Therefore, now Fk equals mu k n. Now, what is the value of Fk? We do have it as 4.6. 4.6 equal to, we do not have the mu k, that's what we are asked to calculate, times n. What is the value of n? It is the 33.95. Therefore, divide both sides by 33.95. So 33.95. Let me try to, it's like we divided the equal sign. Okay, yes, I just wanted to separate them. So the value of mu k now becomes what? Becomes let me use my calculator. 4.6 divided by 33.95 is going to be 0.14. This is our answer, and it doesn't have SI units. If they ask you that question, why is mu k not having SI unit? It's because it is the ratio of two forces. That's the answer that you must actually give when they ask that. So please like the video. Thank you.